So today we'll talk about recursion, and many people say that to understand recursion you need to understand recursion. But this is not completely true because it will take you into an infinite loop. But there is a way out for that, and that we call as a base case. So the question arises that why we need to understand recursion. What is the need of that? So there are two basic answers for this, but the second answer I will give you later in the section, maybe in this video or maybe in another. But the first answer is it has been used by many data structures. Okay, so you can solve any problem with many data structures. Maybe I have missed some of the data structures here, but you can solve many problems with the help of recursion. The another answer for this why recursion, that what I have listed for later point of time, some time. And the main idea of that is recursion is not going to solve your problem in lesser time complexity. Okay, means if you compare recursion with iteration will always be faster than recursion. Okay, so there are some theoretical aspects, and there are some practical aspects also. So that we will talk later, but first we will try to understand recursion. So I have made a small diagram to get to know familiar about the concept of recursion. So suppose there is a line in front of an ATM, and this person wants to count how many persons are in front of this person, means him. He himself wants to count how many persons are there, and this person has two choices. The one, either this person goes to every person and count 1 2 3 and then tells a number that okay, there are n numbers of persons in front of him. But what if we restrict that this person cannot move away from this line, and somehow he has to take help of these persons who are standing in front of him, and he wants to get to know the exact number. So in that case, if this person asks that, oh, how many persons you have in front of you? Now this person has the responsibility. He has transferred his responsibility to this person. Okay. Now the same thing this person can do with the person standing in front of him, and this will go in repetition. And now this person, the very first person is standing in front of ATM, he says that, oh, there is no person in front of him. So now this ATM, suppose it will say, okay, there is no person, so it will return a 0. There is no person, a 0 to this person. Now this person says, okay, I got a 0. Then it will count itself and return a 1 to this person standing back to him. The same he will do, he will add one more and returns 2 to this, and the same 3 4, like that. And when this person got that number, okay, suppose maybe I don't know, maybe 10, but and after this person will return to me, because I have asked this person the question that how many persons you have in front of you. So this whole idea is about the recursion. Okay, so now I want to understand you, to relate you the ATM, the persons. Okay, the question, who has asked the question to this person, all things I want to relate you. So I can say that, don't you think that this ATM machine actually is the base case? Because from here you are getting your first return. First return you are getting that, boss, I don't have any person in front of me. Okay. So you can also say that this person also can return that there is no person. That's another case. But if this person asks ATM that, okay, how many persons? So suppose, let's say that ATM replies, because it is an automated teller machine anyhow. So it says that zero. It returns a zero. So we consider this as a base case. Now this person is the, all these persons are actually stack inside the stacks. So if you see in any recursive code, you fill this stack one by one. Okay. So if I say this is 1, this is 2 person, this is 3, this is 4, and this is 5, and this is 6. So person 1 will be at the down, then 2, then 3, then 4, sorry, then 5, and then 6. Okay. Now when this base case return 0, it returns 0 to this 6th person. Then this 6th person will return the 5th stack plus 1. It adds plus 1 to the 0 and return 1. So if you see, exactly this person got the answer that one person is standing in front of 5th stack. If I relate the person with his stack. Now the 5th stack or the 5th person will add 1 and return 1 plus 1, which is 2, to this 4th person or this 4 number stack. The same goes on, adding 1, and adding 1. So if you see, this person when 1 will get the answer 5, so in front of 1 we have total 5 persons standings. And now if the same return to this person, the answer will be 6. And if this person returns to someone that total number of persons, how many persons you are, it will add 1 and return 7. Now if I relate this in form of computer science, this is the function whom operating system has asked, because anyway this OS will execute the function, so it will return 6 plus 1, that is 7 to the OS, and you got the answer 7. The total number of persons are 7. Okay, so this person has 2 ways to count how many persons in total or in front of whatever the question is. You can modify that accordingly, but the main idea is that this person is not going to count single-handedly that how many persons standing in front of him, but he has distributed his own job to n number of other persons. If you see, so the same, if you relate with this stack, you can relate that each person is actually an entry in that stack, and ultimately it returns to who has asked this question, and that is OS. So that's the concept of a little idea about recursion, that what is the base case from where you return something, and how you delegate the task. You can divide your bigger task to some smaller tasks. So that kind of analogy I try to relate it with recursion, and in future lectures we will talk from very basic to some very hard problems of recursion, and I will answer you the second question, that if recursion is not better than iteration, or even I can say it is always bad in comparison to iteration, then why we are going for recursion. Thank you.